Let's start with the HTTP and HTTPS, the protocols that power the web itself. HTTP Hypertext Transfer Protocol is the foundation of data communication on the web. It enables the transfer of web pages from servers to browsers. When you type a website address into your browser, you are using HTTP to request that page from a server. HTTP operates as a request response protocol. A client, such as a browser, sends a request to a server and the server responds with the requested resources like HTML pages, images, or other content. This happens instantly, making web browsing seamless. However, HTTP has a critical weakness. It transmits data in plain text. Picture HTTP as a delivery service that sends your information on a postcard. Everyone who intercepts it can read what's written on it. This makes HTTP vulnerable to interception attacks where hackers can steal, alter, or read sensitive data like login credentials or banking information. This is where HTTPS Hypertext Transfer Protocol Secure comes in. HTTPS is the secure version of HTTP, which adds a layer of encryption using SSL and TLS protocols. Imagine HTTPS putting those postcards into an envelope and locking it with encryption. Only the intended recipient has the key to unlock it. This encryption ensures that the communication between the client and server is protected and secure, safeguarding sensitive information from eavesdropping and tampering. This is why websites handling sensitive information like online banking, shopping, and email services strictly use HTTPS to prevent credential theft and fraud. Today, HTTPS is the standard. If a website does not use it, most browsers will warn you that the connection is not secure. Next, we have TCP/IP, the most fundamental protocol suite in existence. TCP/IP or Transmission Control Protocol, Internet Protocol, is a foundational suite of protocols that underpins most modern networks, including the Internet itself. Think of TCP/IP as working in two layers. TCP Transmission Control Protocol is like a careful delivery driver. It ensures that data packets are sent and received in the correct order. TCP breaks large messages into smaller packets, keeps track of them, checks for errors, and requests transmission if any packet gets lost or corrupted. This makes TCP reliable. Every bit of data arrives safely. IP Internet Protocol is like the GPS system. It handles addressing and routing, determining the best possible path for data packets to travel across networks to reach their correct destination, even across the diverse networks of the Internet. Together, TCP and IP work in tandem. TCP ensures reliable delivery, while IP ensures packets reach the right destination. When you send a message over WhatsApp, post on social media, or stream a video, TCP/IP is working behind the scenes to ensure your data arrives intact and in order. Without TCP/IP, data transmission would be unreliable, leading to broken connections and miscommunication between devices. It's the backbone of modern Internet communication. When you enter a domain name into your browser, a DNS server looks up the corresponding IP address and directs your request to the appropriate web server. This happens almost instantly, making web browsing seamless. Without DNS, users would need to memorize complex numerical IP addresses for every website they visit, making the Internet practically unusable. However, DNS can also be exploited. Through DNS spoofing attacks, hackers can manipulate domain records to redirect you to fraudulent websites, often used in phishing schemes where you think you are visiting your bank but you are actually on a fake site controlled by criminals. DHCP. Managing IP addresses in large networks would be tedious without DHCP. DHCP or Dynamic Host Configuration Protocol is a network protocol that automatically assigns IP addresses and other network settings to devices. This lets devices communicate efficiently. Imagine walking into a cafe and connecting to its Wi-Fi. Without DHCP, you would have to manually enter your IP address, subnet mask, default gateway, and DNS server every single time. That would be a nightmare. DHCP handles this automatically. When a device like a computer or smartphone connects to a network, the DHCP server assigns it an available IP address from a predefined range. It also provides the subnet mask, default gateway, and DNS server information. This automation makes network management easier. It removes the need for manual IP configuration, reduces conflicts, and ensures each device has the correct settings to operate smoothly. DHCP is essential for modern networks from home Wi-Fi to enterprise systems. Without it, connecting devices would be far less efficient. As the Internet of Things continue to grow, a new type of protocol has become essential. MQTT Message Queuing Telemetry Transport. MQTT is a lightweight publish subscribe protocol designed specifically for Internet of Things devices and applications. Think of it as a group chat for smart devices. It's how your smart home devices communicate with each other and with cloud services. Unlike traditional internet protocols that consume significant bandwidth, MQTT is extremely lightweight and optimized for low power devices. This makes it ideal for battery powered sensors, smart thermostats, home automation systems, and industrial Internet of Things applications. Here is how it works. Instead of two-way communication like HTTP, MQTT uses a publish-subscribe model. Devices can publish data, that is, send messages to a central broker, and other devices can subscribe to topics they are interested in. For example, your smart thermostat publishes temperature data and your phone subscribes to receive those updates. The benefits are significant. Minimal bandwidth usage, MQTT sends only the data you need. Low power consumption, perfect for battery powered devices. Real time communication, messages are delivered with minimum delay. Reliable delivery, MQTT ensures messages are not lost. If you have smart home with connected devices like lights, locks, or thermostats, MQTT is likely powering those connections behind the scenes, allowing your devices to communicate efficiently while consuming minimal data and battery life. As Internet of Things devices become increasingly common in homes and industries, MQTT will continue to play a critical role in keeping those ecosystems connected. Finally, let's talk about QUIC, a protocol shaping the future of Internet communication. QUIC, short for Quick UDP Internet Connections, is a modern protocol developed by Google. It is designed to improve on TCP, which has been around for decades. With TCP, connections need multi-step handshake before data can flow. This adds delay and slows loading times. Think of TCP as a careful handshake. Trust comes first, data comes later. QUIC reduces this delay by combining the strengths of UDP and TCP. Fast like UDP, connections start quickly. Reliable like TCP, data arrives safely and in order. Low latency, fewer back and forth messages mean faster responses. Because of this, QUIC is ideal for web browsing, faster page loads, video streaming, less buffering, online gaming, low latency and smoother play, real-time applications, faster, more responsive interactions. Today, QUIC is already used by platforms like Google, Facebook, and Cloudflare. As adoptions grow, the web becomes faster and more responsive. QUIC is also the foundation of HTTP 3, the next version of HTTP. In simple terms, the future of the web runs on QUIC.